Hi, hello, myself is Dr. Vadiraj Tagore, Assistant Professor, Sri Jagadguru, Totagare Government First Grade College, Munati. In this video, I am dealing with the crystal diffraction session 2. This is program for BSc Physics Paper 1, 6th semester, Karnataka University, Dharwad, session number 2. And in this discussion, my concentration is for Bragg's law and X-ray diffraction. Learning objectives in this discussion is to know the concept of Bragg's law, to understand the concept of crystal structure determination, various methods of determining crystal structure, and concept of cubic lattice. And outcomes from this session is knowledge about the Bragg's law, understanding the 7 crystal system classification, idea about crystal structure determination, clarity about crystal structure analysis. Prerequisites for this discussion is clarity about solids, liquids and gases, what do you mean by unit cell, perfect idea about Bravais lattice, and fundamental concepts about the X-rays. And syllabus for this chapter is X-ray spectrum, continuous and characteristic, Bragg's law, Bragg's X-ray spectrometer, and few problems. Now Bragg's law, Bragg's equation. See here, this is whenever X-rays are incident on a crystal lattice. We know X-rays wavelength is ranging from 0.7 angstroms to 2 angstrom we are using. This wavelength of the light is almost the same with the interplanar spacing or lattice spacing. It is nearly about 1 to 100 angstrom. This lattice spacing and incident X-rays, they are almost resonating each other. Hence, diffracted beam, it gives clearer picture about the crystal. That is the basic principle. It is used by Bragg's equation. See here, ray 1, ray 2. Ray 1 is incident on the first plane, it will be reflected back. Ray 2, it is incident, it is passing to the second plane, it is reflected back. This reflected first ray and transmitted second ray, they are superposed each other, giving rise to interference fringes, diffraction fringes, and this transmitted X-rays on the second plane is passing through the interplanar distance is d, and path difference introduced is d sin theta one side, another side is d sin theta. So d sin theta plus d sin theta is 2 d sin theta, and for constructive interference condition is n lambda. Therefore, n lambda is equal to 2 d sin theta is the Bragg's equation. This basic principle is used in the X-ray diffraction concept. Now, construct interference of the definition of Bragg's law is construct interference of the reflected beams emerging from two different planes will take place if the path difference of two rays is equal to whole number of wavelengths or integer of wavelengths. For constructive interference, n lambda is equal to 2d sin theta. This is called Bragg's law. This is Bragg's law is fundamental rule in crystal diffraction or in crystallography. Derivation of Bragg's law, n lambda is equal to 2d sin theta. See here, this is X-ray number 1, X-ray number 2. So these X-rays, one is reflected, another one is passing through the first plane and reflected back here. So here AB plus BC is an additional path difference is introduced. So AB plus BC, and we know AB is equal to BC. Therefore, constructive interference condition is n lambda. N lambda is equal to AB plus BC, but AB is equal to BC. N lambda is equal to 2AB. Therefore, if you take the triangle, this triangle sin theta is AB is the opposite side, and D interplanar spacing is D is a hypotenuse. Therefore, sin theta is AB divided by D. Therefore, AB is equal to D sin theta. But AB is a condition. Therefore, n lambda is equal to D sin theta plus D sin theta is equal to 2D sin theta. Therefore, derivation of Bragg's law is very simple. N lambda is equal to 2D sin theta is the derivation of Bragg's law. Instrumentation XRD. Whenever this is X-ray tube, whenever if we pass electric current through the cathode and anode nearly 10,000 to 40,000 volts, it is passing through the lead screen. As a result, K beta rays only passing here, and remaining L alpha rays they have been eliminated, and it is incident on a crystal whose crystal structure is to be determined. This is crystal structure. Suppose example crystal structure. This is passing through a transmitted beam is incident on the photographic plate. So many dots, those dots has been obtained. This analysis of this photographic film, we can explain the crystal structure of particular crystal. And we know some basic ideas. Unit cell. Unit cell is the smallest geometry which represents characteristic property of whole crystal. This unit cell classification is based upon lattice dimensions A, B, C and interfacial angles alpha, beta, gamma. And we know primitive cell. Primitive cell or unit cell is the smallest geometry which represents characteristic property of the whole crystal. And we know lattice plus basis is called crystal structure. Lattice is periodic arrangement of a points in a space. Basis is if a lattice point is attached with an atom or a group of atoms, it becomes basis. This lattice plus basis is called crystal structure. Previous lattice. So there are 14 lattice points are classified into 7 crystal systems. This classification of 7 crystal systems from 14 lattice points is called previous lattice. These previous lattices are cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic, trigonal, depending upon A, B, C and alpha, beta, gamma. These are in cubic. There are three cells: primitive, body center, face center; tetragonal, primitive, body center; orthorhombic, primitive, body center, face center, and base center; hexagonal, primitive; trigonal, primitive; monoclinic, primitive, and base center; triclinic, primitive. So these 14 lattice points are classified into 7 crystal systems is called previous lattice. X-ray diffraction methods. There are generally used for investigating the internal structures and crystal structures of various solid compounds. They are Laurie's photographic method, transmission method, back reflection method, Bragg's X-ray spectrometer method, rotating crystal method, and powder method. In case of X-ray diffraction method, there are 3 methods. One is called Loy method, rotating crystal method, powder method. Which method is suitable in which situation is, in case of Loy's method, orientation of a single crystal, polychromatic beam, fixed angle. In case of rotating, lattice constant, single crystal, monochromatic beam, but variable angles we can choose it. In case of powder, lattice parameters, polycrystalline powder, monochromatic beam, and variable angles we are using. Transmission by Loy's method. So in the transmission of Loy's method, the film is placed behind the crystal to record the beams which are transmitted through the crystal. One side of the cone of Loy reflections is identified by the transmitted beam. The film intersects the cone with the diffraction spots generally lying on an ellipse. Can be used to orient crystals for solid state experiments. Most suitable for the investigation for preferred orientation conform to the lower diffraction angles, also used in the determination of symmetry of the single crystals. Bragg's X-ray spectrometer method. Crystal is mounted such that theta is equal to 0 degree and ionization chamber is adjusted to receive X-rays. Crystal and ionization chamber are allowed to move in small steps. The angle through which the chamber is moved is twice the angle through which the crystal is rotated. X-ray spectrum is obtained by plotting a graph between ionization current and the glancing angle theta. Peaks are obtained. Peaks corresponds to back reflection. Different order glancing angles are obtained with a values of determinant spacing d and order of diffraction n. From the observed value, we can measure the crystal structure exactly. Determination of crystal structure by Bragg's law. X-rays falls on a crystal surface. The crystal is rotated and X-rays are made to reflect from various lattice planes. The intense reflections are measured by Bragg spectrometer and the glancing angle for each reflection is recorded. Then applying Bragg's equation, ratio of lattice spacing for various group of planes can be obtained. Ratios will be different for different crystals. Experimentally observed ratios are compared with the calculated ratios. Particular structure symmetry will be identified in this method. And rotating crystal method. Whenever X-rays are incident on a crystal mounting, this will be rotatable with the various angles. The X-rays are incident here and the diffracted beam is incident on the photographic plate. Analysis of this photographic plate, we can estimate the crystal structure. Photographs can be taken by complete rotation method. In this method, series of complete revolutions occur. Each set of plane in a crystal diffracts 4 times during the rotation. 4 diffracted beams are distributed into rectangular pattern in the crystal point of photograph. Oscillation method. The crystal is oscillated at an angle of 15 degree or 20 degree. The photographic plate is also moved back and forth with a crystal. The position of the spot on the plate indicates the orientation. Intensity of the light can also be identified by using this method. Powder crystal method. X-ray powder crystal method is called XRD. Is a rapid analytical technique primarily used for phase identification of a crystalline material and can provide information on unit cell dimensions. The analyzed material is finally grounded, homogenized, and average bulk composition is determined. This is also called Debye-Scourier method or Debye-Scourier camera. Here inside photographic film has been loaded and X-rays are passed through the filter, and these X-rays are incident on a crystal and the diffracted or reflected beam is incident on the photographic film, and after uh, deposition of the X-rays we can analyze the X-rays film and we can estimate the crystal structure about the theoretical ideas. Fine powder is struck on a hair with a gum. It is independent vertically in the axis of the cylindrical camera. When a monochromatic beam is allowed to pass, different possibilities may happen. There will be some particular out of random orientation of small crystals in the fine powder. Another fraction of grains will have another set of planes. The reflections to be occur. Reflections are possible in different orders for each set. So this is Debye-Scourier method, and setups are here. So whenever X-rays are passed here, it is incident with the crystal. Various cone form like these lines. This is one line. This is another line. This is another line. In this way, these lines are formed. The spacing between the two lines, intensity of these lines. So this photographic film with the two holes, depending upon the position of these lines, intensity of these lines, we can estimate the crystal structure. This is a film, X-rays passing through the reverse Fourier camera. X-ray film is obtained. In this way, we can estimate the crystal structure. So by using this, we can estimate the crystal structure, various crystal structures like this. So if you have any queries, any questions, you may just WhatsApp your queries with for this number. We will try to answer your queries. Thank you one and all for listening my lecture. Thank you one and all.